I'm pleased that we've got some folks from the National Estuary Program here, Jason Kudulis and Blair Morrison. Blair did her undergraduate degree at UA, was part of the Distal Summer Program, and wound up working with Jeff Krause before earning her master's and then moving over to the NEP. Jason said the opposite pattern, did his undergraduate in geography at South and then master's at UA. How long have you been with the NEP? It's been almost 10 years. So anyway, they got to talk a lot about the work they do, both we think of them as the estuary program, but they do a lot of stream work and things that affect the whole watershed. So I'm excited to learn about the breadth of all the stuff they do. So without further ado, you guys come on.
Well, hello, everyone. Happy Friday to you. Thanks for joining us. The fried pickles were delicious. I had a few so we'll see if they pay off. So we're with the National Estuary Program, and I'll start off with saying you see that we're a division of the Dauphin Island Sea Lab. When we're down here on the island, which isn't as frequent as we would like, we always like to remind everyone that we are one of you. And so if we can ever help you in anything, don't hesitate to reach out. We have a vast library on our website and a big Rolodex of partners and resources that potentially could serve you. So I'm glad to be here today. We're going to start off with a little background of who we are, just to let you folks know that may not be familiar. And then we're going to talk about stream restoration. And then Blair's going to talk about the monitoring and science that we want to do to understand those pre and post impacts of these projects. So without ado, I got it. Don't worry. Well, Melissa was touching this last, so we'll blame her. All right, so the National Estuary Program, there are currently 28 of us. We are established by Congress, and we are considered an estuary of national significance. It looks like our friends in Mississippi are getting ready to reach that establishment, as well as our friends over in Perdido. So this model of the National Estuary Program started out of 1987 amendments to the Clean Water Act. We're non-regulatory, non-advocacy, and our entire purpose is to build local, place-based collaboration for the wise stewardship of the water quality and living resources of coastal Alabama. So even though we are a federal program and EPA is kind of our umbrella, they really don't mess with us much. It's everything that we do is going to be driven by our management conference. And so it's a collective of resource managers, elected officials, scientists. Obviously, we're a science-based program, grassroots, business and industry. All of us come together for this management conference, and we meet at least 3 times a year plus an annual meeting. And at our the center of that is our executive committee, which is a representative from EPA and Commissioner Blankenship representing the state of Alabama. And so our charge as this collective is 2 things. One is to have a management conference that, again, takes into account what people in coastal Alabama say is valuable and important to them. And it's to put that into this overarching management plan, the comprehensive conservation management plan. And we are in the midst of creating our 3rd. These are typically 5 to 10 year plans. And so we've been going the last couple of years holding focus summits and meetings with our management conference to figure out the goals, objectives, and activities that are going to drive coastal management for the next 10 years in Alabama. And so the kind of main tenets of what we do with our work in this comprehensive conservation management plan is our estuary status and trends, right? That's our science. That's our, how do we even know what we're doing if we don't understand the current status or the before and after? And Blair's going to share that specifically later on. We have our ecosystem restoration and protection. That is our shovels in the ground type projects, right? That's when we're actually going in and rehabilitating or restoring our natural resources. We do a lot of technical assistance and capacity building, whether that's working with local government, grassroots organizations, or the private sector, figuring out how they can become better stewards and get involved not only with our program, but through different aspects in the community, because it's kind of a high tide lifts all boats, right? We need them thinking about regulations and ordinances and best management practices for their sector that all kind of feeds in to what we're doing collectively. It's kind of collective impact is our model. And then you have your general education and public involvement, right? If y'all been to bays and bayous, or you've been and seen some of our Clean Water Future videos or commercials on TV, there's that newsletter, Alabama Current Connections, free. They'll mail it to your house. We do that with the state 2 or 3 times a year. Great publication to always just figure out and be up to date on some of the things going on with the Department of Conservation Natural Resources in our program, right? And so when we're really humming on all cylinders, and what we're going to talk about with these stream restoration projects is all 4 of those tenants have a role, right? The central to that is restoring that habitat, but there's that status and trends, that technical assistance, and that education and public involvement. That's when I really think we do our best work. And so central to the National Estuary Program is this idea of watershed management, comprehensive watershed management, where we're meeting these EPA key elements of what a watershed management plan should be. And why I'm saying that is because it's central to the Doe watershed that I'm getting ready to talk to you about, because it was kind of the poster child for this. Just as the oil spill was taking place, we completed the first watershed management plan for the Doe watershed on the eastern shore of Mobile Bay. And why that's important is because it served as this model, right? After the oil spill happened and we started getting these once in a lifetime monies, the state and all of our partners said, how do we use these monies wisely? You know, where do we figure out where the stressors are, where the needs are, where the priorities are? What are the thoughts of the communities? And a watershed management plan takes all those things into account. And so everything I'm getting ready to talk to you about was a proof of concept. And it goes to show you that it worked because the state and those dollars eventually funded completion of watershed management plans for all tidally influenced watersheds. So if you guys have an interest in a particular watershed or an area of focus, these are great resources that provide science-based community involvement specific to those HUP 12s, so you can drill down and really start to figure out what you need to do there to better manage those resources at the watershed scale. All right, so Doe, getting into it. Well, Doe, believe it or not, we started with the worst one. Like to prove a proof of concept, you're hoping you kind of, you know, lob up something easy. Well, Doe is what we call the poster child of stormwater runoff and stormwater impacts. It is absolutely more difficult than any of these other ones that we've even came across as far as degradation of stream channel and stream banks as a result of urbanization. And we call it the perfect storm of stormwater runoff and impacts because it's got these unique characteristics. On the left, you see the contours. If you've ever driven in Daphne, Spanish Fort, it's like sometimes you're headed up, you know, a highway in Appalachia, right? There's a lot of elevation if you've been in the Lake Forest community. Their soils are highly erodible. These things crumble. As you know, we get over 60 inches of hard rain. Just earlier this year in April, some places in Doe and Spanish Fort got 15 inches of rain in less than 4 hours, right? That was almost a 500-year event. Think about what that does when it hits these impervious surfaces and then has to collect volume and velocity, hit these stream channels, it blows them out like a fire hose, right? And so that's the problem that we're dealing with. Is this is a small 8,700 acre watershed, but it's highly urbanized and developed. And some of these sub watersheds are actually over 60% hardened or impervious, right? And so when you see this curve, we're talking about taking these natural drainages and they're basically becoming urban drainages, right? The stormwater runoff, it impacts the entire hydrograph. So you see the non-dash line, traditional hydrograph, right? You kind of have that slow up and down. And when you have these development, you see those more harsh trends, right? And that's where I'm talking about, instead of having that returning into groundwater and going through our wetlands and some of that natural reduction of energy, these things are coming off the streets, the car lots in Malbus, and they're hitting this watershed again like a missile. And so that's the impacts that we're going to try to correct, right? Like I said, real easy one to start with. And so this is an image of Mobile Bay from 1974. You notice there's no Gaillard Island, there's no causeway, but the Lake Forest community was being developed even as long ago as then. And at the time, it was the largest residential complex in the state of Alabama. So, you know, lo and behold, they didn't know all those factors that were going to be going against them as far as building this out and thinking about all the ingredients I just talked to you about. And so even into that, the best management practices of those times probably were not on par to what we're doing today. And so the work that I'm getting ready to share with you, I want you to think that it was more reactive. This watershed was so far behind in discovering all these issues with it as a result of that 2010 watershed management plan. We're just trying to put the pieces back together, right? This thing was already falling apart, where you have this mass wasting, you have this stream bank erosion and unstable channel, where you're just leading to all this sediment going into downstream waters. And so this project was funded by the National Fish and Wildlife Foundation, Gulf Environmental Benefit Fund, 8M 319 monies, and other local dollars to really figure out, like, we did these early projects in Joe's Branch, but we want to do some holistic watershed restoration. And so how we were able to dovetail that into those oil spill dollars is because these downstream sediment impacts were going into Doleave Bay, which could potentially harm SAV, which could potentially harm resources that were impacted by the Deepwater Horizon. And so that's our goals, is to mitigate sedimentation and water quality impacts to receiving waters. And it's interesting because when you do these watershed management plans, they are science-based, but everyone has an opportunity to come to the table. And when you look at what we've done today, holistically, and you see this map of Doleave, in the middle there is Lake Forest, right? And that's where everyone was worried about that sedimentation. So all we kept hearing was, we want to dredge the lake. We want to dredge the lake. We want to restore its capacity. And that's when you started this idea of, well, there's no sense in putting money into that large effort until you stop the bleeding, right? So you notice a lot of these projects are in the headwaters of this system because that's where they started falling apart. And the way that this erosion works, these head cuts, they actually go upstream. So when you have a point of instability, it actually runs up. Think about pulling a thread on a dress or a shirt. You start tearing at that thing, it only gets worse. But in this case, it goes upstream into those more fragile and sensitive headwater systems. And so you see the bulk of what we've done today has been pretty significant. It's over $16 million invested in the delisting of one of these sub-watersheds. There's 3 main sub-watersheds: Joe's Branch, Doleave, and Tallahassee. We hope to see all 3 of those delisted with time, but geologically, after we finish these projects, they have to heal, kind of settle out, and you stop that transport of sediment where you can get in there and monitor. We did learn if you monitor after a restoration project in the early days, you're really just spinning your wheels and wasting money because there's still so much active sediment in that system, even after construction. And so, but that is the first stream delisted as a result of these restoration techniques in the state of Alabama. And Joe's Branch on its own is like a square mile, and it was putting out over 25,000 tons of sediment per year. So it was like, as you know, if you had a scale of 0 to 10, this thing was a 20. And we were able to show over a 95% reduction as a result of these techniques. And so think about a typical cross section of a stream, right? You want floodplain connectivity, you want hydrologic connectivity to those adjacent riparian buffers and freshwater wetlands. Well, what happens is what we're talking about with these head cuts is you lose that. And so it's kind of that Grand Canyon effect. You don't have that ability to spread that energy out to the edges, release those nutrients and pollutants into those natural filters. This thing starts to down cut and you lose that connectivity. Not only are you harming those systems that are adjacent, all that energy is being exerted on the center of that channel. And again, so how are we going to mitigate that? How are we going to correct it in a way that uses nature-based solutions or natural channel design? And that's exactly the approach that was adopted, right? So this is this holistic approach to not only mitigating the impacts of that urbanization and those stormwater impacts, but how do we maintain or enhance or restore the ecosystem services and the ecological function of these sensitive systems in a mostly urban watershed. And so this is kind of the hierarchy of how we go through that process. We start by doing bank erosion, hazard index, morphological assessments. We're looking at the entrenchment ratio. We're basically creating, for the engineers, we're hiring professional stream restoration engineers to create us a basis of designs, right? And a lot of times what we're actually doing is some of these reactive stream restoration projects that we're doing are so bad, we're going back and creating a brand new channel. So what you're going to see of before and after is literally we borrowed material from here to create a new channel, put it in the old one and filled it in. So we're actually starting over from scratch. But some of what we do in this engineering and natural channel design is also do some hydrologic and some hydraulic modeling, right? Where we can look at the stress of the design. Think about stretching a slinky. You know, you can kind of pull that in and out and figure out based on the energy that's going through there in a 100-year storm, or let's say a 2-year storm, how is that stress going to be exerted? And that design is going to figure that out and armor it more where it needs to be and keep it more natural where it's not. And so some of the techniques that we use are tow wood and riprap on these bends of the river, right, where you're seeing that energy exerted. On a bend, we use cross veins and riffles. And what we're trying to do here is handle that energy, that volume and velocity, and keep it steered toward the center. So if you guys were to go trout fishing up in the, uh, around Boone or Asheville, we're almost mimicking some of these practices, right? But we're doing it down here in the coastal system because of the energies that we're dealing with today in these systems. And so the idea with these is, again, we're trying to keep that energy within the center of the channel, because on those edges is where you're going to have that stress that could create an area of instability where that channel may migrate, create a new channel, or start to collapse and erode. And so when you think of it, it's all grade control, right? We're starting at a higher elevation, and as that water's moving downstream, it's a lower elevation. So we're putting in a series of steps as we go with these riffle pull sections and armoring on those bends so that we can control the grade as it's progressing, right? And so if you're interested in it, it's fluvial geomorphology. Kind of the head honcho of that is Dave Rosgen, Rosgen. He kind of is the father of some of these natural channel design practices. He holds these courses. He has books. So it's really an entire sector of its own that you can dive into. And so what do some of these projects look like, right? So before and after. So we're essentially, you see where we're talking about the Grand Canyon effect, right? And they not only get deeper, they get wider. So as you lose that vegetation and root mass, these things just start collapsing in on themselves. So, these systems shouldn't be natural gullies like you think about in Fairhope and Montrose. These should be your typical, that cross section with a floodplain connectivity. So before and after, before and after. And so when we build these projects, some of what we do to incorporate even more ecosystem service and uplift is we're using native vegetation. We're using landscaping plans where we have different vegetation on the toe of the channel, the floodplain, and the uplands, right? We're using pollinator blends. And I'm showing you some of these shortly after construction so you get an idea. But the idea long-term is like this picture on the left, you don't even see that anymore. Those trees are 20 feet tall now. So we're rehabilitating that to where you don't even know we've been there, right? These are wildlife corridors. These are natural systems along these tributaries, which, as you also notice, have human infrastructure. So we're not only protecting property, natural resources, we're protecting this infrastructure as well. And so depending on the environment and the energy, we use more wood or more rock. If we're working in close proximity to homes, you kind of want to get in there and not have to come back, right? These people are agreeing to do these projects with us. And so we're trying to do due diligence to be right by them. So when you see, this was actually Joe's branch here, where it was, again, as bad as it could possibly be. This was the first time we implemented what's called a step pool stormwater conveyance, where we're simply a series of steps. And when you go there today, you wouldn't see any of that. It's one of our oldest projects, and it looks like a natural wetland riparian area. You have to hack your way into it. So it's almost fully restored. And I will say that this not only handled the April 2014 historic rain event, Hurricane Sally, but also the April 6, 2025 event. So these are proven techniques that last with these 100+ year events. It's pretty impressive. And so we constructed this model. It worked. The pilot, we eventually are doing all those watershed management plans. And then how do we now expand this proven technology of natural channel design or in-stream stormwater systems that restore ecological function, right? That's like the long fancy term for it. So I'm going to show you a couple of other examples of where we've implemented similar projects. And so in 12 Mile Creek, the headwaters around between Cody and Hillcrest, if you know where Foreman Road is, when I was in school at South, there used to be a cut through. I don't even think you can get through there anymore off of Dickens Ferry. This is the headwaters of 12 Mile that then goes down by the botanical gardens into Langen Lake, right? The city's restoring Langen Lake, but it was the same idea as Lake Forest. Why should we dredge the lake until we've stopped these sediment inputs? And so we were able to do this project along with some apple snail eradication in the lake. You see, this is shortly after construction. Again, we're planting that with native vegetation, different shrubs, trees, and grasses and plants. So again, over time, it just blends right back into the landscape. We had a comprehensive program that we were calling Dolly 2.0, where we were going to go into the lower Fish River area of the Weeks Bay watershed and the Magnolia River watershed to replicate these same things as well. And so we identified some projects again where you see that stream has lost connection to the floodplain. You notice when you see that root mass, trees falling in, these are kind of just like smoking guns of when you stumble on a site that this is probably not an appropriate way that it should be. This is actually at the outfall of this drainage. So you see this little private marina. This thing had filled in over 3 times and this community had dredged it out themselves. So think about that mass wasting that I'm talking about, with sending this material to downstream waters. And so for us, again, that same natural channel design where we come in, regrade the entire channel, elevate the channel by bringing it up, either through building a new one or correcting the existing one. And so what I want to point out here, though, is sometimes we're able to do other things as we work with these private landowners that benefit the community as well as all parties involved. So this trailer was a nuisance. It was abandoned. You could see it was about to fall in this gully up there in the top left. So as part of the project, we were able to remove that. We were actually able to get the county to vacate this road that was a cut through for litter and nothing good. And it was also taking stormwater off an intersection back into this. So we were able to work with partners. And so when you see this site today, it looks pretty impressive. And so it's about 3 years old now. And so it's regrowing in really nice. And that's in the community of Marlow down at the intersection of County Road 9 and 32. And so more recently, as part of this lower Fish River watershed restoration, we also just completed within the last month stabilizing 4 non-contiguous bluffs on the Magnolia River itself. So not even a tributary or a drainage. This is actually on Magnolia River proper. And if you see the people standing on the left and the right, these were 30, 40 feet bluffs south of Highway 98 on the Magnolia River that, again, we were able to come back in, stabilize, and actually remove some of that vegetation within the channel itself. We kept some for habitat, but that was causing it to plug up or preventing recreation, right? So that's another ancillary benefit when we're in there doing these construction practices. But total, this was about 900 linear feet. And then our biggest project to date is just to the west of here on Schoolhouse Branch. This is just east of the town of Magnolia Springs. You can see that you had that significant bank erosion. You can see that it lost floodplain connectivity. And this thing had experienced several of those storms as well over the year, right? And so this is what it looks like just as of a month ago. And this is 3,100 linear feet. This is the largest stream restoration that we've done here in coastal Alabama. And this project, again, you're seeing that temporary vegetation. You're seeing some of those in-stream features. And it looks pretty good. So with all that, I'll say that we're fortunate to be able to do this work and work with all of our partners and scientists and engineers to construct these projects, and also the private landowners that entrust us to do these things. And so I'm going to turn it over to Blair, and she's going to talk about some of the great work that we're doing to make sure that we are seeing those positive impacts with these. So
thanks, Jason. So I'm going to talk about some of our pre and post restoration monitoring strategies. My favorite one, of course, is BOCEPHAS. BOCEPHAS stands for Box of Cool Electronics for Understanding Sediments. I named it before it actually was an acronym, but then one of my coworkers asked what it stood for, so I created one for it. But BOCEPHAS is a really awesome piece of technology. This is called a sediment system. And essentially it has 3 main parts. So you have a sensor that measures water turbidity. So that is the little sensor in the purple box. There's a pump apparatus. If y'all are familiar with ISCO auto samplers, that's what the R2D2 looking thing in the blue box is. And then there is a data logger in the orange box, which is essentially the brains of the operation. It catalogs all of the turbidity data, and it'll essentially catalog whenever a sample is taken. So let me see if I can get this video to work. Maybe. All right, so this is just a little kind of close-up of Bocephus. So data that's collected by the turbidity sensor can actually trigger the ISCO pump to sample water when certain thresholds are exceeded. And this allows us to remotely sample water over the duration of rain or storm events. As you all know, if you've been around here, you don't necessarily want to be outside during a lightning storm with like a bucket, taking samples. And so this allows us to do this and to take samples when it's otherwise kind of unsafe to be out there. Also, we get a lot of rain events at night. You don't want to be out, sampling at night. And this system is equipped with telemetry. So this allows the monitoring array to actually send us updates via a cellular network. So I would get emails from it. I was like, oh yeah, turbidity threshold exceeded, or, come check, the rosette of samples is full. So that's really helpful just in terms of like time management and resource allocation. We didn't have to drive all the way over across the bay every day to check on it. So what is the purpose of Bocephus? The kind of final product is we're creating a TSS, a total suspended solids, and turbidity correlation curve. The way this is done is we have all of these samples in this rosette at the bottom of the ISCO. You can see there was a very large rain event. These are pretty kind of chocolate milk looking samples. Once we take those, they're rehomogenized, we transfer them, and we worked with Dr. Alex Beebe at the University of South Alabama. He did all of our sample analysis for us. Essentially, these samples are rehomogenized, they're filtered through a glass fiber filter, and those glass fiber filters are combusted, they're weighed again, and that lets us know how much solid was actually in that sample. And this allows us to correlate turbidity, so the in situ measurement, with the amount of sediment that was actually being transported in that sample. And this ultimately allows us to estimate the total suspended load of sediment in a water body at a turbidity value. So Jason touched on this, but why do we use Bocephus? Again, monitoring turbidity and suspended sediments using an established protocol. This is something I want to bring up. Of course, you can see the sediment plume from D'Olive in that picture, the Landsat image. This protocol is actually used by the Alabama Department of Environmental Management to list and delist streams for the 303D impairment list. So this is something that is really important in terms of the methodology, because it means that we are directly comparable with a state agency. We actually worked very closely with the agency to get all of their SOPs, their methods, make sure that we had all of the same equipment. So hopefully those data are apples to apples, and we can assist them in the delisting or listing of those streams. Or at least show, hey, we have equivalent data. Can you come in, do your own study, and list or delist? Also, just in general, sediment is considered like statewide. It is the biggest pollutant of concern for state water. So sediment is kind of a core pillar in all of our restoration activities, is trying to handle sediment issues. So as Jason mentioned, we have these two sites in Lower Fish River or the Weeks Bay watershed. We use Bocephus as part of our post-restoration monitoring strategy in Marlow, and then our pre-restoration strategy on Schoolhouse Branch. So you've seen some of these pictures before. Marlow, just the scale of the head cutting here is pretty significant. And the bluffs that you see in the bottom right at Schoolhouse, those were over 14 feet tall. And you can see that those kind of pipes going across, those are actually exposed infrastructure. Those are cables and stuff for telecom. So definitely an issue that needed to be addressed. So we put Bocephus out. The data I'm going to be showing you today is from Schoolhouse. So we put Bocephus out in like summer of 2023. And here's just a couple of things that we learned along the way. Just in general, we experienced over a 100-degree temperature swing within the internal thermistor of this equipment. So our hottest temperature was 123 degrees inside our housing. The coldest was 16 degrees. So it's really important, learning kind of opportunity for us, just knowing that you have to have really robust instrumentation for this kind of work that can deal with those temperature swings. We actually had to put a vent in the top of the box just to help with some airflow and some thermal regulation. But then, of course, with adding holes to the box, then you get some critters that like to come in. So another thing that was really interesting using this technology is we were able to capture some of these really intense rain events. We know it rains pretty hard here. And in some of these instances, we had precipitation rates over 5 inches of rain per hour. So another learning opportunity here, making sure that you've weatherproofed all of your equipment really well. And all of our equipment was grounded with really big copper wires as well. You don't want lightning to fry your equipment. As I mentioned, the critters. As much as we tried to keep the wildlife out, they will find a way. And the frogs really enjoyed them, enjoyed hanging out in the box and all kinds of insects. And so another learning kind of moment, we ended up putting a lot of rubber gaskets to try and seal things a little better. But just being aware that you might encounter wildlife when you're going and checking on the sampling site is definitely important. And this is a really big one. I think this is probably the biggest thing that we learned. Expect the unexpected. So this is when we first deployed Bocephus in 2023. And this was a couple months later. I think something has changed pretty significantly. Yeah, so we had a beaver decide to set up camp. And so we actually put out a trail cam, which is something that I think we're probably going to keep doing on future projects just because it's cool. We want to see what kind of wildlife is using these corridors, but also it's helping us to identify potential issues. So we had this beaver working really hard overnight, and that all culminated in the day before we were leaving for Christmas. Our instrumentation went offline because the beaver decided it wanted to have a snack. So the moral of the story here is, even if you don't think there are beavers in the neighborhood, armor all of your equipment. Armor everything. We ended up having to run all of our cables through PEX tubing, corrugated pond hose. We put anti-chew cable guard on it to, like, I think people usually use it for like cats and rabbits. Beavers are just giant rodents, so sure. We had to get a little creative with how we were doing this. So Jason was on top of the NEP mobile, getting all this done. But justice was served in the middle of 2024. We had a huge rain event and the dam got washed away. I was like sad, also a little like, yeah, okay, cool. So overall, was this worth it? We could have just had somebody out there taking samples, or we could have had just a singular sonde out there. Overall, even with all of the trials of everything, yeah, it was absolutely worth it. So we collected over 24,000 turbidity readings during that time period. Over 200 water samples were collected, which is actually above the threshold that the state usually uses for listing and delisting. Over 20 individual rain events. We had a crazy turbidity range, anywhere from 0 to over 2,000 NTUs. So really showing us how much sediment and how turbid this water was getting in these big rain events. And we got to see that the hydrographs for both Marlow and for Schoolhouse were really flashy. So again, as Jason was mentioning, in the systems that don't have very good connectivity with the floodplains, you essentially have a huge spike when rain happens, and then it goes back down pretty quickly. There's not any kind of lessening the slope of that curve. Again, ignore the gap in there. That was beaver, reset time. And then this was our resulting turbidity curve, our TSS turbidity curve for Schoolhouse. This is saying that basically 96% of the variation in turbidity can be attributed to TSS, or TSS and turbidity. And that's actually really cool that we have that close of an agreement. And ultimately what this does is this allows us to just put out a turbidity meter for monitoring this site instead of having the whole system. And we can still use that as a proxy for how much sediment load reduction has happened as a part of this project. Another cool thing about this too is all of those points that you see in that kind of orange box, those were all taken when the beaver dam was in place. You can see that the beaver dam actually does have a totally different relationship, and it changes the relationship between turbidity and TSS while those structures are in place. So it's just a aside, like, that's pretty cool. Of course, I have to acknowledge all the people that helped make this happen. Jason and I built Bocephus in our conference room, much to the chagrin of our neighbors in the office. And of course, our funding partners and folks that helped make this happen. Lots of swimming in beaver ponds in those pictures. And of course, Alex, BB for helping us process our samples. So that is Bocephus. We're actually getting ready to deploy Bocephus again, probably somewhere in Baldwin County, hopefully before November, so we can get the next kind of hydrographic year. So yeah, that's a really cool piece of technology that we have. And I will also kind of talk about, kind of switching gears a bit, some additional pre-restoration monitoring work that we've done, particularly on Schoolhouse. We wanted to, because this was the biggest kind of restoration we had going on, and there was a lot of canopy cover here, we wanted to have a better understanding of what the biotic effects of this restoration would be. So we ended up doing a fish and a crayfish survey of this stream before construction. We got to go electrofishing, which was very cool. And we did 3 different survey reaches, kind of upstream, midstream, and downstream. Bocephus was stationed kind of at the end of that 3rd segment there in the yellow. And these are some pictures like from actually walking the stream. So you can see kind of the difference in the topography in certain sections. You have really tall bluffs. Sometimes you have wider areas that are pooled. So there's a lot of different kind of microhabitats that could be in this creek. And we wanted to know what was there before we move to construction. So after construction, we can see what species are going to come back. So these are some of our awesome finds. There's a really big, fairly large, largemouth bass that was actually utilizing the creek. That was pretty surprising, I would say. Lots of really cool darters, this black-banded darter, lots of different kinds of sunfish, shiners, chub, and then a really cute white tubercled crayfish up there, and some mad toms, which are little catfish. So this is just kind of a table of all of those species that we caught. And it's interesting to see what stretches or reaches of the stream certain species were using. Some of them we saw across all stretches of the streams, and some of them we only saw either upstream or downstream. And so this is really important, again, for us to establish a baseline for what species are there, how they're utilizing the habitat in certain areas. So then once the construction has time to settle, we can go back, do another survey, and see if these species are coming back and recolonizing these habitats. So with that, I know that was a lot of information, but that is our presentation. Please let us know if you have any questions.